Okay, so I made a video previous to this that was 2 hours long, but it ended up being pretty much me spending 2 hours trying to get the build scripts working for AI improvements. Yes, this is the mod we actually are working on today. It's the mod I said I was going to work on yesterday, but well, plans have not been going smoothly for a while. For example, the plan was to get up at 10 a.m. this morning and work on this mod, but unfortunately I got up at 1 and I spent the last 2 hours trying to fix a build script that turned out to not be the build script's fault, but to be a cache's fault. And well, caches are caches. Anyways, so we are working on this mod, and it is pretty much updated. So if we actually popped over to the code, I didn't have to do anything. Like there's been like one line of code that has changed between all 5 versions. I think there's like maybe one AT line that's also changed between all 5 versions. Of course, I'm not 100% sure on this because I didn't update 3 of the versions myself, but I did look at the Git repo, and there really wasn't a lot of changes. Like if we go all the way back to like where you see 1.8 and stuff, so it's like right here is roughly when we started working on the new versions, and you like look at this and there really isn't a lot of changes. There's things like the tests were deleted, and if you sit here and you scroll through it, there's not any code that was really changed. It's just the same repeat things, like tests were removed and some build script changes. You can keep scrolling forward, and eventually you'll see things like there was some minor problems that were changed, like some method names were rechanged, but that was it. Like this code, surprisingly, this is one of the few mods I've had that I expected this to fail. As I've been saying in previous videos, I've been saying all week on Twitter as well, is that I expect this mod to have failed horribly at one of the versions, but it didn't. Like nothing went wrong. Now, of course, we do have a bit of particular issue. We need to confirm the mod is functioning. We need to confirm that things are running, that code is being called, that there is a performance gain. Because if we can't prove any of that, then well, it's a junk mod. So let's start with this. So this is the first part. One of the main things that does work, every time an entity has been added to the world, it will fire an event. It'll go, okay, are you a living entity? It'll go, okay, hey, you're a living entity. Then it'll go, okay, hey, do we want to remove the look editor, or we do want to do anything else? So we want to remove look idle. And if those 2 booleans were configured, of course, it would go through and it would actually remove those from the thing. Of course, they're not. Instead, we replace the look helper as what's actually enabled. This will go through, find the previous look helper, which is the vanilla look helper. It will make a brand new one, which will encapsulate and try to use the previous one if possible. And then it just clones and converts everything else over, and it runs our tan function, and it runs perfectly fine. And the ideal is that this will run faster than a normal tan call. At least that's the theory of the thing. So we got this code. We know this code works. We know everything else works, of course, because we confirm that configs are being loaded. We know that the fast trig is being initialized. This is, by the way, what the fast trig is. It's a really basic method. I built this for a class project like way back, and I just went ahead and cloned it. And of course, I did have to go look at some other people's code to make this function too, because even though I understand what this thing does, sometimes it doesn't work perfectly the way I wanted it to. But it does work, actually, so there's nothing wrong with it. And how it does is it just decides, okay, we have so many bits of precision, and we're going to go, okay, based on that number of bits of precision, we're going to say, okay, if you are 5.00003, you're the same as 5, is what it essentially does. And it kind of improves the speed of things just a little bit, and that little bit makes a huge difference. And so it does do its job. The next part, actually, this works, which actually, by the way, this class is dead, so I'm going to actually delete this. I probably should delete that a while ago. That's one of those ideals where we're going to probably rewrite the AI look helper, or look class itself. So we have the helper, which we have rewritten, but then there are actual AI tasks that depend on the look helper that do function. And the ideal is like, well, if we're having problems with the very task itself, maybe we can improve the task. Maybe we can go, okay, change it and tweak it around. But the first thing is we change the look helper, because everything does depend on the look helper, and most mods use the look helper straight flat out without changing anything. Especially since in one of the versions, I believe the look helper became a final object and it's not supposed to be changed. And we went ahead and changed it, of course, because theoretically it should work. So let's go ahead and make sure this is running. So it is running. It does do the look thing. It does update rotation. The update rotation part, I believe, is the code that, well, actually doesn't run that bad. So this is where you just kind of wrap your degrees and you're trying to figure out where you want to aim your face at. And it works out. Do a few different things. It's the tan function is what we want to do. So it's right here is where we want to run it at. We want to see when that actually gets called. And here we go. So you see that actually gets run, and it ends up with the same result as you would normally expect. And we can compare the two eventually, and we can see what happens when you don't have it, and you do have it enabled, which we're going to do real quick. So first things first, what I want to do is we're going to kill off the client, and then we're going to pop over to AI improvements, and we're just going to turn this event off. So this event is actually what controls all the functionality. So if it's turned off, it doesn't work. So therefore, we're going to have a vanilla-esque like game running, and we're going to launch in debug mode with Visual VM enabled. And what we're going to do with this is we're going to sit here and we're going to watch how mobs behave and what our stuff is. So we're going to run like a 5-minute run of looking at stuff, and this is kind of how this works, by the way, is that you get like a monitor and it'll show you how much RAM you're using, and it'll tell you like the top line is the total amount of reserved RAM, the blue is how much RAM you're actually using. There's a difference. It's the reason why people go like, oh, well, I'm using like 5 gigabytes of RAM. The reality is you're not actually using 5 gigabytes. You probably are using like 3, and there's actually just 2 reserved for spikes. You see how the spikes up and down? You can control this maximum RAM, by the way. It is controllable. And you get down here, you get some threads going on, you get some other things. And by the way, with this, you can run the sampler and a few other things, and you can actually keep track of what's running and what's doing what. You can see like how idle stuff is running, kind of like pretty much how hot the program is running is a good way to put this. There's ways to detect for hotspots and a few other things. So you can go all threads. You can actually do like live-only threads. So that way you can ignore dead threads. And there is a color map. So purple is sleeping. So these map threads at the bottom are basically dead. Green is running. You got parked. You got waiting. There's a lot of waiting threads, unfortunately. A lot of these do come from other libs like Java 2D Disposer. So the only ones we care about are the running ones, and one of these should be the game itself. Like right here's the main one, and it's going to go into a lot of sleep cycles. You'll watch it actually do that. I just got poked. Oh wow, I haven't heard from that guy in a long time. Yeah, one of my clients from I thought had completely disappeared on me actually popped back up. So we're going to run the sampler, but we're going to wait till the game runs. And actually, you're seeing it actually already is running, and you're watching it sleep, so it'll pop back up every so often just to check to see what's up. Go into here, and as soon as we start to actually do stuff, you'll start to see the main thread become more active. And you're going to see like this little pause between here, and the pause will be pretty consistent. We're going to make a new world. We're going to make a creative world. We're going to do more world options. Turn generation of structures off. We want a super flat. I kind of really wish there was some ways to turn mob spawning off, because I want to get a pretty much empty world. It's really hard to get that to do that, though. If we had Volts Engine updated, I could use one of my empty worlds, and that would have been a perfect way to test this, because then we can confirm like how much CPU just one sheep is using, and that would have been a perfect baseline, because it would go, okay, hey, this is using this much, this is using that much. And I don't see any actually around us. There are some entities though, and this is the problem with trying to run this, is that we aren't going to have the consistency because we have a whole bunch of things. I don't see, well yeah, as soon as I said that, there's sheep everywhere now. So I'm trying to think of like what mob could we use that doesn't normally spawn. And we're not going to be able to do it the way we want to do it. So what we're going to have to do is we're just going to have to be obnoxious about our spawn rates. Ooh, what are these things? Mundane lingering effects. I don't. Those are new bottle types I've never seen before. They've probably been in there forever, and I just completely glanced past them. I'm still getting used to the whole 112 thing. I still haven't gotten used to the fact that the miscellaneous tab is down here instead of up here, because you got these save toolbars, and I still haven't figured out how to use these. Like you're supposed to hit like Control 1 to use them, and I don't know. I've never got it to work. So we want some spawn eggs, which I think have now been moved down to here. And I want sheep, and we're going to be, actually, you know what? Let's try mushroom cows. By the way, all these entities do use the same code, so it shouldn't make a difference if I just like spawn a ton of them. But I'm hoping that Visual VM will catch on to just this entity for me, and that way I can go like, hey, I just want to see this entity's runtime. It's really hard to do though, because well, all this stuff uses the same thing. So we want the sampler, and we want to do a CPU sample, and we're going to let this run. And I'm going to really quickly take a snapshot while it's running, just so we can view it. The sampler, of course, is still running, but we can sit here and look at the thing, so I can kind of point out what we're heading for. So we want to look at ticking, we want to look at updating entities. And here's where we're starting to see things. So we're starting to see on update, and you're seeing travel, which is something we might want to optimize. Is a lactic flag. What? Okay, so we're looking for AI scripts. And I'm not seeing them in this thing here. This is the base ND, by the way, it's running. Of course, there's slimes running over here, which you're seeing them do move handler updates, which isn't taking up too much time. Here's horse updates, which have got a little bit more runtime than I expected. I'm not seeing what I want to look for in here. I'm not seeing anything, to be honest. I'm sitting here looking at this like there's really not anything in here. So that snapshot may not be very valuable. Let's sit here and just walk around real quick. What I want them to do is, what they're supposed to do is look at you. It's like that one's looking at me. That's the kind of code that actually ends up really messing with servers and stuff. Is that there's a lot of tan math running around just to make sure they're looking at you. And it's not just looking at you, they could be looking at random things around here. So you notice how like their head will look at random stuff. And there's a randomizer function that goes, hey, I want to look at some random spot over here, just to make myself look lively. And it does take up a bit of time and does actually eat up CPU. Okay, so we should have a good enough snapshot now. Okay, so update light into something. So this is a server thread, but why am I only seeing entity update lighting? There's a world server update with optional force, entity living. Okay, here's the on update. We're having trouble getting our baseline here because I having trouble finding just where it is in the code here. So there's update entity action state, which I think might be, oh, there's some navigation. So there's some pathfinding stuff we could optimize here later. Collision nearby, update. You know what? This is one of the things that I was kind of worried about, is it may no longer be that big of a problem. Or it may not be noticeable until you get like a massive amount of entities. But I'm not seeing like anything in here. So there's a piece of code I'm looking for to run, and I'm just not seeing it run. And it could just be the way I'm running my snapshots here. Or could I be in the wrong thread? Like here's the server thread, here's the client thread. Maybe this stuff went client side and I just don't notice. Nah, because we would see something here. There's update display. Nah, it's not here. Okay. So this is definitely still running. So CPU sampler is still in progress. And then let's take another snapshot. Okay, server thread, ticks, entity tracker, no. So it should be world update entities, is what we should be looking at. But I'm not seeing the AI updates in here, which is weird. They're just not showing up in the system. There's like on living update. So like you get the grow time and you get the living update cycles. There's entity action states. We were just down. Haha, I think I found it. On update task. And you're noticing it's not really. Yeah, here's what we're looking at. So this is the AI look idle time, and it's not even showing up any time on my computer whatsoever. And this is where I was saying this doesn't really become a problem until you get a lot of entities, and we only have like maybe 100 around us. And who knows, Minecraft may have optimized their code. So let's pop over here and let's go look at their code. So this is Minecraft's default code. And they do have, so they're just running normal A10 met functions. This is where I was saying like these don't run exactly as that they should. Actually, it looks like they did something to them. These aren't, this method doesn't look the same as it used to. Do they have their own cache? I'm not seeing it. Oh no, I'm seeing some stuff like this. Coast tab, baseline tab. So they do have what looks like some kind of cache here. They may have already implemented their own, yeah, because they have a sign table right here. So there's a sign table. There's a square root helper here. So the whole thing I may have implemented. Yeah, because they're using sign tables here. There's a sign table here. So the reason why we may not be seeing this is that, well, Mojang implemented the code I made. That's not saying they copied my code. This stuff is like, you can find it anywhere online if you ever want to find it. But it looks like they have been improving their math code, which is kind of cool. Which means this whole code set we're working on is, frankly, not very useful anymore. But we do have a baseline, so we're noticing it's, yeah, not using anything at all. The code that we might want to start looking at optimizing then, if this isn't really helping, is starting to optimize pathfinding. And like, pathfinding is even optimized too. I think they've spent a lot of time working on their AIs. I know a few of the developers for the game were tweeting out that they were optimizing AIs, they were doing things with AIs, they were doing like cool little tricks and stuff to kind of improve the handling, because they knew this has been a problem for a long time. It does look like there is some stuff, room for improvement. Not a huge amount though. The trick is AI improvement still actually has advantages though, because you can flat out turn off pieces of code with it, which it does actually then free up CPU time, even though it comes with some really weird results in the process. So let's see. So we got our baseline. Let me actually just run another snapshot while I'm at it. Grab CPU. Oh wait, I did not want to hit that button. I want to hit this button. Okay, so yeah, so we got total time of about 437 seconds. That'll work. And then we want to save this guy to the desktop. No mod, and we'll just export. That way we can compare it, because when we go to shut down Minecraft here in a second, it will close the virtual VM. Or well, it won't close it, will lose connection basically. But now we want to enable the mod, and we want to see if there's any difference noticeable. So if there's any difference whatsoever, even if it's like really small, I'm going to keep this functionality of the mod because, well, it has a benefit. If it takes longer, then I may want to go ahead and disable this functionality because it's actually making it more detrimental than it is helpful. Let's go to, actually, what did I just hit? I just ran it with coverage. Close. I did not want to run with coverage. We don't have any JUnit coverage, so there's no point running with coverage. Unfortunately, we're now going to have a whole bunch of red lines on the side over here. So this will run again, and well, as soon as we get one in the world, we'll run the sampler, and then we'll use that to determine if there's an advantage. If there's not an advantage, then we'll just scrap that piece of functionality, and we'll look at other ways we can improve it. There are alternative approaches to this. So instead of, say for example, actually using this as intended, we can, well actually no, I'm going to leave this piece of code alone, but because this is the fixed version here, is that we can say, okay, let's go edit the actual AI scripts themselves. Instead of updating the look helper, we can say, okay, try to look at something less often. Just doing that simple fact would cut down CPU usage. Then you can say, okay, travel around less often. That will cut down CPU usage as well because you're not pathfinding as often. We could say certain animals don't pathfind at all. We can also go, okay, sheep, stop trying to edit blocks around you. So that's a really big thing. Like if you have a ton of sheep in an area, they do trigger block edits because they eat grass and it turns into dirt. So we can turn that functionality off. That would save some CPU there. We can spawn less monsters and less animals, and that would save some CPU problems. There's a lot of little things we can do that would still be beneficial and would still make this mod actually usable. Because there's not a huge amount of mods that do exist that do just focus on performance gains out of changing small little tweaks to the thing. I mean, of course, you got Foam Fix, you got Fastcraft, you got Optifine, of course, but outside of that, there's not a huge amount, especially ones that just focus purely on this. Anyway, so we want to start our baseline again. CPU baseline. Really, the big thing is, like, when you actually sit here and look at this, you'll notice a whole bunch of OpenGL calls. I actually found out that this is not as bad as it was. In the LG get error, you see this show up a lot here. It's not horrible. I removed this out of a game I'm working on. I was like, oh, if that's showing up like 25% of the time, that must be bad. And you remove it, it doesn't really make any difference. That 25% goes somewhere else. It's not that this was taking up your time. It's that this was just being called excessively. That's where you want to compare not only self-time, but you want to start looking at like different things. So you got this self-time, you got that, but this is what you want to actually look at, is how long did that method actually take to run? Is that little thing there? Because that's not big. But then you look at some of these other things and they start to take up a lot more time, and etc. 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 There's total call. There used to be like a total call field on here, and I wonder if you can still change this. Samples. I think that actually will tell us what's going on. There used to be a hotspot detector in the building for this as well, but I think it got removed. Yeah, there's still a hotspot right there. This is technically a hotspot detector. Not being very useful in the whole explaining how the system works, because, well, I need more training myself on it. Okay, so we should be able to look at this, and we should be able to come down through here and pretty much go to the same spot we were last time. Well, if this was actually functional. Here we go. Maybe? There's a zombie right there. That's cool. I don't care about zombies, to be honest. That's a biome spawning piece of code. Unfortunately, it didn't catch the code I'm looking for, and I'm kind of curious why it's not showing up. So let's get rid of that snapshot, because that's not very useful. Let's do time set day. And then these guys are still staring at me, so we'll just walk around them real quick to get them to keep re-triggering their code. And then we'll check it out again. So we want a snapshot. Then we want to go to server thread. Yeah, let's see if it actually catches the code running this time. I think it actually did. I'm not even seeing it in here anymore. I can't imagine my code is running that much better than Mojang's. I mean, it was that insignificant of a runtime to start with that I may just need to flood the world with entities to get it to show up as a significant change. The thing is, it should show something here, because when I originally ran this, used to do these mods and work on them, like you could see noticeable changes. Here's a network tick. Like, we're not getting anything here. Like, the integrated server is doing squat. It's in sleep mode. It's running that well. It's in sleep mode. So we need to figure out some way to trigger it so we can sit there and watch that method and see what it does. But I don't want to add any more entities to the world, because that would, in theory, devalidate any testing we were doing. And there's some graphic glitches with their heads. I just noticed that. Only when you're at certain angles, like right there. Huh. Open GL for you, I think. Barely noticeable. It could be because they're running really large planes and they're doing some stretching and a few other things. And we're just seeing like some shadowing and artifacting. Okay, so we ran around a little bit more, and let's get another snapshot to look at and see if we can detect for this. If I don't see it in here, I'm just going to say it actually is doing its job properly. But then again, at the same time, this was such an insignificant amount of CPU usage that it just may not be showing up. Okay, for starters, let's make sure that our code is running. Yep, it's running. Just running that well, maybe. Yeah, using Visual VM is coming up with inconclusive tests. So we can't confirm which is running better. I have a way to do this though. So we're going to have to ditch the idea of using Visual VM for this, because the code isn't showing up in here. That, or I'm so out of it that I'm missing it, which actually I might be. Oh, there's update method in here. Let's handle water movement stuff. Like, I can't tell if my computer's just running really, really well or what's going on here, because if you look at this, we're in sleep way too often. We're sitting at like 98% sleep, and I may just get a copy of the server from one of the admins here and do the test with that, because we know we're having a problem and stuff. So the way we're going to do a test with this is we're going to make some tools. Source main, so we're going to make a package here called tools. And then here, we're just going to actually do it this way. So we just copy this guy, pop back out, paste in here, and we'll go all the way in here and build broken. We're going to rename this to tools. And then this will be AI improvements. That's what this would be. Actually, we don't need it. We're just going to delete the package. That way, we go over here. We go hit project structure, sources. We can come over here and go, okay, that's a source package. So it'll now show up. So we'll see a tool package here. And we're going to make a new class, and we're going to call it main performance test. Now we need to kind of cross our fingers on this one because we're trying to run Minecraft code outside of Minecraft and it doesn't always work. But we're going to hope that it does. So what we want to do is we want to take our version and we want to directly compare it against their version. And we cannot do this directly. So what we want to do is we want to take this guy. So this is the AI look helper for this. Actually, can we fake this? No. We could if we had some tools and stuff to do it. But I don't want to add a whole bunch more libs to this. So we would need an indie living, which I think we can instantiate. I'm going to try to instantiate one because I think it'll work. So we're going to go entity living. Proof class. Entity living. Oh, we don't want to do that. Let's try entity zombie. And then we'll set the world to null. So this is just basically an empty entity we're going to use. And then we're going to build 2 look helpers. Even though the entity itself is going to have a look helper in it, we're just going to build another one. So this will be MC helper. Any look helper. Can this actually be imported? Yeah, it can. Okay. I was worried for a second that might have been a protected class. There's times when that actually does happen. And let's make sure this doesn't depend on world in any case for its runtime. I'm not seeing any calls to world. Because if it did, then we would have to scrap this item and have to try something else. So this does look okay. Everything looks fine. So we got that. And what we really want to do with this guy is we just want to kind of run some randomized calls on it. And we want to force this to do things. So for starters, we want to set is looking to true every time we run this. So we're going to go for... there's also a trick with this too. I'm going to run both look helpers at the same time. And the reason I'm going to do this is because this will give us some definitive results and will prevent optimization from running on both of them at the same exact time. So we want to do int I equals 0, I is less than 10,000, I plus plus. And we're going to want to make our version of look helper too while we're at it. So this will be just called helper, and this will be, of course, fixed entity helper. And we're going to make sure they're both the same type over here, that way where the same commands are being run on both. So first thing first is going to call MC helper dot is looking true, and then we would call helper dot is looking true. So that way we set them both to default. That way the piece of code we want to run is this guy, and that requires that this be true. And I don't think... How does this actually even work now I'm thinking about it? Like, is there like an actual target position you set with this? It looks like you do set a target position with it. So we're going to need to set a target position randomly. I'm going to just say... Does this do yaw and pitch? Yes, it does look at this job pitch. So we want to come up with some kind of random coordinate system, and this will be pretty simplistic. We'll just go and set both of them to the same coordinate. So we make sure these both are set to true every time we run it. And then we want to come up with a coordinate system. So we go int x equals 0, int y equals 0, int z equals 0, and then we'll do create a rand function up here. Come on, there it goes. Why does it want an input? It doesn't want an input. Why is it being weird? Okay, I think we got it good. So we're going to want to randomize this, and we want to make sure we randomize this in such a way that we do get different numbers, but we kind of keep it within a certain consistency. So we would go next in, and we want to set a bound, and we would say, okay, we would look within 10 of ourselves, but then at the same time, we want to minus it by 10 as well. So that way we get the negative inversion numbers as well, so it's not always the same. We only want to do this for the x and the z because the y we don't want to go too high. So for the y, we want to just do 2 up and 2 down because that seems reasonable. This will give us our location data. And then we go mchelper dot pos x equals x, and we just repeat this process over and over again. Do y, gives z, and we're not looking to see if this code is functioning correctly. We're trying to just see if it runs better. Because correctly is a different thing, so there's efficiency versus effectiveness, and effectiveness-wise, I think the code works. So we don't need to check that. Both these 4 versions, I believe, have been tested rather well, and we could make another tool later if it proves otherwise, but we'll check that in a bit. So this will set our coordinates, and then what we want to do is just run an update looking, I believe. So we're going to call mchelper.update looking. And we're going to want to track that here in a second, and then update looking. So we're going to get a log both of these. So we're going to long start equals system.nanotime, and then of course start equals system.nanotime minus start. So this will give us our actual number, and we're just going to repeat this for the other one as well. And we'll just store it here real quick. Actually, I'm going to print it out the console, and then that'll be how we're going to do it for the first moment, because I'm not going to sit here and build a whole bunch of logging programs in this episode. I've done it many, many times. You can find other episodes where I've done this, and I don't really care for a logging program at the moment. So system.out.println, and all we have to do is make sure that we don't run print lines in well, you guys get the point, but we don't want to run these inside the start thing, because print lines are actually kind of slow. So put that in there, and we're not going to be able to format it because I don't have a lib to format it right now. I can add one, but that means the compile time will be dependent on it, and I don't want to do that. So this will be the BBM version, and then we'll break it up so we can easily read it by just putting some long dotted lines between each one. And then we'll do like an integer that will go like, hey, this is run number something. So we know which one we're on. And this should work. So we're going to go ahead and start this. And we should see like spam on the console for days. Oh, okay. So this is where I always talk about those inconsistencies, because you see this runs in 254, that's 500. The Mojang one seems to be pretty consistent. No, I take it back. Right there's a long one. There's a really, really long one. This is where I always talk about there's optimization code that runs. So if we go all the way to the beginning, here's how long you start to see things run. And it keeps running really, really slow. You see for sure, though, that the BBM one is ahead of it, all except for that first run. I can't tell if that's because, oh yeah, it's because the cache has to initialize, so we screwed something up here. We did bias our result here by not running something real quick. Fasttrig.init. I forgot to run that. Load the cache. I don't know if Mojang's version has a load on that, but if we do that, that will change our results here by a significant amount. We run, and let's see what happens when we run this 100,000 times. So we're going to run this. And by the time you get to the end, ignoring these last two because I don't know what happened here. These are like outliers. Same with that one right here. We have to like, when you do statistics, if you start seeing numbers that are so far outside your data set, these are called outliers, and you just ignore them because something happened to cause that to do that probably wasn't part of the original. But you look here, like the sad truth is these are running just as well as each other. There's not a lot of significant gain, and you see sometimes it runs faster, sometimes it runs the same, sometimes it runs slower. And this is where we would need a chart and graph to kind of watch what these are doing. And I can't see the starting conditions either, so this is where I definitely need some charting. But I'm going to say they both run about the same, with the BBM1 running a little bit faster in some cases. I know it's a little bit biased in me saying that, but the results are pretty consistent. Let me make sure we are running... Yes, I'm running helper here. There's MC helper there. And these are both different versions. They run about the same time. So it looks like Mojang did implement code to make their version run better than it used to. Because when I used to run tests like this, you would see like a significant gain. And now the gain is not significant. We're getting like a 3 or 4% gain out of it now. I'm going to go ahead and give it to them for the server because there is a gain nonetheless. And then I may also recommend if it gets bad enough that they can automatically just turn the AIs off. And then I'm going to go ahead and add more code to this so they can do even more and more with it. But good. So let's go ahead and upload this code. I don't know why there's import changes there. Code coverage log, and we want to ignore that. Ignore stage file. Okay. There is an important thing to note with the TAN cache is that you can technically increase the gain by reducing the bitrate, and it would start to run significantly faster than Mojang's code. The only disadvantage of doing that is that you lose precision pretty badly, and it means skeletons are going to miss even worse, but it won't be just skeletons that will miss. It'll be like a little bit of everything will stop functioning properly. That is one of the disadvantages of a cache like that. Speaking of which, if Mojang's implementing a cache and I'm implementing a cache, that means our caches are really close to each other. That's kind of interesting. It means I might want to drop my cache over here. I'm doing... I have no clue, actually. Oh wait, this is not what I'm looking at. This is where you can see I need coffee today. So if you come down here, we go to the fast trig. The cache looks like an 8-bit system. I don't remember how this works. It looks like I did keep the log of where I got it from originally, so we could go look at this. But it does look like we're using 8 bits to store the precision rather than, which I believe a float is a 16 or 32. So we are dramatically reducing the precision, which is how we're kind of running performance. We could, in theory, run a full cache here, and it would actually work out really well, but you would, I think, use 100 megabytes of RAM to do it. So we're going to leave it there, because I think it only increases the RAM usage by like 1 megabyte, but the mod works. So we know this for sure. So I'm going to close this video out, and I'll see you guys later.